Today we start with the next chapter of physics in standard 8th, that is force and pressure. As per the textbook Concise, it is the third chapter, force and pressure. Now, first of all, in the first part of the chapter we'll be taking only the force part. So we'll first understand what is force and then we'll go to pressure. So force, we have learned up till now in your previous years, that is maybe 6th and 7th standard, that force is that physical quantity which when applied on a body would either change the shape of the body or the size of the body, or it would be making a body start moving, means it was at rest and it starts moving, or it will stop a moving body, or it could also change the direction of the moving body. So in this way, you know that the different things what a force can do to an object is that it can either make it start moving, that is it was at rest and start moving, or it could be that it is moving and it is stopping it. Okay, that is the second thing. And the third thing could be, if it is moving, it is just changing the direction of the motion. Okay, so this is about motion. If you're talking about motion, what can a force do to the body with regards to motion? With regards to motion, it can either start a body or stop a body or change the direction of the body. That is one thing about force. The second thing is that if the body is not a rigid body, it is a soft body like that, a squeezy ball, or you can say a clay, then what will happen? If you take the clay and you press this, what will happen? It will just get deformed. It will change in shape and size. So the other thing what is possible with the help of the force is to change the shape or size of the body. So accordingly we can say that force is that physical cause which either changes the state of rest or of motion of a body, or it changes the shape or size of the body. Okay, so now we see what exactly is written as per the textbook. So we go ahead with this thing. In class 6 you have read that force is a cause, push or pull, which tends to result in movement or change in size and or shape of the body. Okay, so this is what they say, that you had learned earlier that force was that particular kind of a cause which is going to tend to change or results, or which results into a change in the motion of the body or in the shape or size of the body. A force when applied as push or pull, okay, when you push, that is dhakka marna, and pull yani kheenchna. Okay, so when I am pushing somebody or pulling somebody something, so when applied as push or pull on a stationary body which is free to move, can produce motion in it. So if I am having this particular this pen over here, I can push it so it is moving further, I can pull it to bring it backwards. So in this way this force can make it go forward or backwards, that is it can cause a stationary body to move. Secondly, it is applied, it can change the speed of motion of the body. Okay, let's take an example over here. Change the speed of the body. Football खेलते वक्त somebody kicked the ball and passed it to you. It was already in a very good speed. What did you do? You kicked it further to just increase the speed. So what happened? You as a person, you hit the ball which was already in motion, and you made that ball go faster than what it was already going, right? So that what did you actually do? You changed the speed of motion, and the speed, it can also slow down. Like, of course, किसी ने ball फेंका तो तूने सिर्फ पैर रख के उसको slow down किया. You just slowed it down. Like you are the goalkeeper, so you are slowing it down. So depending upon what exactly is the kind of force you are applying, either you can increase the speed or decrease the speed. In fact, you can also change the direction of speed. फुटबॉल का एग्जांपल लेते हैं. किसी ने तुम लोग को पास किया, so ball was passed to you. You just hit the ball in such a way that you change the direction of the ball towards the goal. So what did you do? You just applied a force so that the direction of the ball is towards the goalkeeper or the goal. Not keeper, of course. Keeper को क्यों दूंगा मैं? Okay, goal. So it is going into the goal. So the direction can also be changed by the application of force. So you see that force can change the type of motion which is taking place on the body. Either it can increase the speed, decrease the speed, stop the ball, start the ball, change the direction of the ball. It can change both the speed and direction of the motion. So yes, it can change both the speed as well as direction of the motion. Like cricketer, when the bowler is bowling the ball is going to come in front of you. What did you do? You hit it in the direction of the bowler. So automatically ball आ रहा था तेरे पास और तूने क्या किया? You hit it away from you. So what did you do? You changed the direction, plus the ball came at particular speed and then you hit it very hard. So the speed of the ball was automatically made faster. So it can change the direction as well as the speed of the object. So this way the force is going to help you in changing the direction or speed or the motion of the body. So there are some examples over here. A grass roller initially at rest when pulled begins to move. Okay, of course we do not have too much of lawns over here, that we don't have bungalows over here, that we know what is a grass roller. Grass roller is basically जो तुम लोग के ये स्कूल के ग्राउंड के अंदर जो ग्रास है उसको काटने के लिए they will be having some kind of a machine. That machine is just a machine which is going to roll and keep on cutting the grass. So that is called as the grass roller. So that grass roller initially is at rest, and when you're pulling it out, the grass roller starts moving. So that is why take the grass roller. Take a simple example of the trolley which you take in the mall. So the trolley which you go to Big Bazaar or somewhere and you take a trolley, and the trolley was at rest, and when you pull it or push it, it is going to move forward. So that is initially is exactly the same as the grass roller. The fielder, when catches the ball, stops the moving ball. Okay, so fielder, ball came to it, he stops the ball, he catches the ball. So he basically applying a force. A moving car slows down and applying a brakes on it. So a car is moving and the brakes are applied, the car stops moving or it reduces its speed. So this is also because of the force applied by the body on the car. A push or a swinging girl speeds up her swing. So when the girl is swinging, okay, by girl, anybody who is swinging, the girl is swinging on a swing, at that time what it does, somebody pushes that particular girl. So what happens? Swinging increases. The swing or the speed at which she is swinging is going to increase. A player, when applied force by his hockey stick on the ball, the direction of the motion of the ball changes. So that's exactly the player, and he is hitting the ball with the hockey stick, he is changing the direction and the speed of that particular ball. So when force is applied, a stretch or squeeze on a body, when it is not free to move, it changes the size and shape of the body. So you can see that the early examples, the examples were such that when I am applying a force on the body, there is no change in the shape or size of the body. It is never going to happen कि मैंने फुटबॉल का बॉल को किक मारा और फुटबॉल का बॉल पूरा ऐसा पिचक गया. It is not going to happen. You are not going to have anything like, okay, a cricket का short ball लिया और when I hit that ball and the ball became flat. Okay, never. It is never going to happen. Okay, so that's why those objects which are going to have a change in its motion, they are normally solid, that is rigid. So we call them as rigid bodies. Okay, so that's rigid body. So a rigid body will be the one on which when the force is applied, that is going to give rise to change in motion. Okay, the change in motion is going to take place on a rigid body. But if it is not a rigid body, means it's not a hard body, but it's a soft body, so then it is called as a non-rigid body. So when it is a non-rigid body, at that time when the force is applied, this force is going to bring about shape and size may changes. So change in shape and size is going to come into picture when it is a non-rigid body. So when it's a non-rigid body, it is going to be this. Like for example, if I take this handkerchief, what is going to happen? I'm doing this. What has happened? It has changed its shape and size. Now the moment I pull it, it will become bigger. So automatically now what has happened? It has just extended further. So it is a non-rigid body. That's why this, when the force is applied on it, it is changing its shape or size. So that's how the things are going to change. So when force is applied or stretch or squeeze on a body, when it is not free to move, it changes the shape or size of the body. For example, on stretching a rubber string, its length increases. Rubber band liya, usko khicha, its length increases. Squeezing a tube of gum, its shape changes. You take the gum tube, toothpaste le lo, toothpaste kaisa dabate kya hota hai? It deforms, it changes its shape. So this is how the change in shape or size is going to take place when the force is applied on a body which is a non-rigid body. Okay. Thus, we define force. Now, it's the most important part. That's the definition of force based on whatever we understood up till now. So, what is force? Force is that cause which changes the state of body, that is, change of rest or of change of motion, or it changes the size or shape of the body. Okay. So, we saw two things. One was change in motion, that is, change of state, that is state of rest or of motion, or size and shape of the body. So what is force? Force is that cause. Force is that particular cause which is going to bring about the change in the state of rest or of motion of a body, that is change of state of the body, and or change the size or shape of the body. So you can see force is that cause which changes the state of body, that is that either the state of rest or state of motion, or it changes the size or shape of body. So it is changing the size or shape of the body. We have to note here, a force does not change the mass of the body on which it is applied. मैं ये डस्टर पे कितना भी फोर्स अप्लाई करूँ, it is not going to even reduce its mass by even 1 gram. So it is force will never change the mass of that body. Second, we cannot see force, however we can see or feel the effect of force. We cannot see the force, but yes, we can see the effect of the force, because अगर मैंने कुछ चीज को push किया या pull किया, तो the motion, with the change in the motion which is taking place, so that we can see. So I cannot see the force. So when I applying over here, I cannot see I applied a force over here to make this move, but that force I cannot see, but I can see the change which is taking place over here. Third thing, the force is expressed by stating its magnitude and direction both. So now, very important. Force cannot be expressed only by magnitude. I cannot just say, okay, I applied a 5 Newton force on this thing. It will not solve the purpose. It will not tell me exactly what I'm meaning. I need to very well bring into effect over here that what is the direction in which I have applied the force. Like for example, when it is like this, I say I have applied a force of 5 Newton on this body. It could be I applied a force like this also. It could be I can apply a force like this also. It could be that I can apply a force like this also. Or I would apply the force like this. Or I would apply force like this. So in each one, if I just tell you that, okay, apply a force on the table of 10 kg. So won't you ask me, sir, in which direction I have to apply the force? Is it towards me or towards you? Or even is it towards the side or it's towards the wall? I will need to tell in each and every case that I need to do a certain work. Hence, you need to apply the force in that direction. In a tug of war, will you be applying a force that you are releasing that person? No, you are going to pull that thing. So when you are pulling the other team towards you. So the direction is important. Okay. So every time the force will be applied in such a way that you want it to be in a particular direction. Hence, the force will always have two things in it. One is the magnitude. What is the magnitude? Magnitude is nothing but the numerical value. 5 Newton, 10 Newton, 15 Newton, 100 Newton, 1000 Newton, तो मैग्नीट्यूड है. प्लस direction is which direction I want to move the object, whether I'm moving it in the north or south or upward, downwards, जो भी हो. Okay, depending upon what is the direction in which the force is applied. Hence, for force, both the things are important, the magnitude as well as directions. That's why we are given over here, a force is expressed by stating its magnitude and direction both. A force is represented by an arrow. The length of the arrow is a measure of its magnitude and arrow shows the direction. So you can show a force in the form of an arrow. So if it is an arrow like this will be another arrow, something let's say like this. I know that this arrow is smaller, so the magnitude is small. This arrow is bigger, so the magnitude is big. This is in this direction. That let's make if suppose this is the east direction and this is the west direction, then this is towards the east and this is towards the west. Okay, so the direction is by the arrowhead, which is pointing out to that particular direction, and the length of the arrow will give you the magnitude. Of course, we are not going to measure the length in each of the case, but it is a possibility that you can always give two arrows showing one as smaller and other as a bigger one. Then it will indicate that the bigger one has got a higher magnitude and the smaller one will have a smaller magnitude. But normally you will not represent it in at least in our chapters, we are not going to represent any force in the form of the length of the arrow. Yes, direction, yes we can, but not the length. Okay, or in fact direction also we normally write over there towards east, towards north, or upwards, left, downwards. We normally write that. We don't show it as an arrow because many times very difficult to show it in an arrow. Like how you will show upwards, like लिखा हुआ मैं upwards कैसे दिखाओगे? Okay, that is upwards, that maybe north also, south also. Anyway, we do not worry about that right now. Now we come to the unit of force. So the SI unit of force is, so force is measured in a unit which is nothing but Newton. Okay, now remember this cannot be capital N, it will be capital N only if it is in the symbol form. In the symbol form I will write it as capital N, but when I write it as a name it will be N small, because capital N with the Newton over here will be referring to Sir Isaac Newton, the scientist. But when I am taking the Newton as the unit, it will be small n. But when I am using it as a symbol, it will be capital N. So you need to remember this thing. Yeah. So the symbol for Newton is capital N. This unit is named after the English scientist Sir Isaac Newton, who did a lot of research work for force. So he was one of the very important person who worked a lot on force, motion. So all the laws of motion and everything is based on the principles which Sir Isaac Newton has formed. Okay, so there are many important things which we will be studying in the later years also. In fact, in 9th standard and 10th standard itself, you got a good amount of thing about motion which is based on Newton's laws of motion. Okay, so 1 Newton is defined as a force which when applied on a body of mass 1 kg in the direction of its motion increases its speed by 1 meter per second in 1 second. Okay, so this is the definition of force. Let's understand this definition so that you are not having any confusion over here. So you are given that 1 Newton is defined as a force. So I am saying over here 1 Newton is the force which when applied on a body of mass 1 kg. So it is 1 kg mass. Okay, 1 kg mass into in the 1 kg mass which when applied on a moving body of mass 1 kg in the direction of its motion increases its speed by 1 meter per second in 1 second. That means it is going to increase the speed by 1 meter per second So that will make it as 1 meter per second square. That is nothing but called as acceleration. Okay, you need not worry about this thing because it's not in your syllabus as such, but you can understand this. When I say that the speed increases by 1 meter per second in 1 second, that means that is 1 meter per second square is the acceleration. That is how much the speed is going to increase every second. See, तुम लोगों को मालूम रहेगा when your dad is driving the car, he is normally going to press the accelerator, and when he presses that accelerator, the speed of the car increases. So what is that accelerator? It is the one which is going to accelerate, that is going to increase the speed. So that is basically over here that 1 meter per second, if the speed is increasing by 1 meter per second in 1 second, and the mass of the body is 1 kg. So if suppose this is the body and I apply a force, and this body is of 1 kg. Okay, if the body is of 1 kg, and when I apply a force on this body such that its speed increases by 1 meter per second in 1 second, then that particular force which I applied was equal to 1 Newton. Okay, so what is 1 Newton? 1 Newton force is the force which when applied on a mass of 1 kg produces or increases the speed of the body by 1 meter per second every second on each or in 1 second. Okay, so that's why it is 1 Newton is equal to 1 kg into 1 meter per second square. Okay, so this is how you get it as the force, or you can say the definition of 1 Newton. Further, we have read that our earth attracts each body towards it. The force of attraction exerted on a body or by earth is called as weight of the body or the force of gravity on the body. So one was I applying a force which is giving me a particular kind of increase in speed. That is one thing. Another thing is this body is being attracted by the earth's gravitational force to fall down. So the amount of force which is acting on the body due to the earth's gravitational force is called as the force due to gravity, or nothing but weight. Weight is equal to force due to gravity. Okay, the gravitational force. So we see over here the force of attraction exerted on a body by earth is called the weight of the body or the force of gravity on the body. The force of gravity or weight of the body is different at different places on earth. At a place, the force of gravity of the on a body of mass 1 kg is called as 1 kgf or 10 Newton. In other words, 1 Newton is the force of gravity at a place of 0.1 kg, that is 100 grams mass. Thus, the unit of force kgf and Newton are related in this way. So, what do we understand? 1 kg, okay, 1 kg is a mass. Suppose this is mass 1 kg. Then the force of attraction by the earth on this thing will be given as 1 kg mass produces a force equals to 1 kgf. What is 1 kgf? It is nothing but the force of 1 kgf exerted by the gravitational force. Now when I see this thing and I convert it into Newton, I find over here that 1 kgf is equals to 10 Newton. Okay, 1 kgf is actually speaking it is 9.8 Newton, but we will for easier thing, so that's why nearby we can't say it is around 10 Newton. Okay, we don't need to take 9.8 right now. We can just consider it to be as 10 Newton. So that's why 1 kgf is equals to 10 Newton, or 1 Newton is 0.1 kgf. 1 Newton is how much? 0.1 kgf. What does that mean? It means that 1 Newton is the amount of force applied on a body by gravity of mass 100 grams. Because we know that 1000 grams make 1 kg. So when I say, see it is this way, that 1 kg is equals to kgf is equals to 10 Newton. So 1 Newton will be equal to 0.1 kgf, which is nothing but 100 gf. 100 gf means what? The mass of the body is 100 grams. So if 100 grams, suppose this duster is of 100 grams, then the amount of the gravitational pull on this body will be nothing but 1 Newton. Why is 1 Newton? Because it is 100 grams. 100 into 10 will be 1000. 1000 grams is nothing but 1 kgf. 1 kgf is nothing but 1 Newton. So accordingly it will be this way, that 100 gf is equals to 1 Newton. Okay, 100 gf, 100 grams is 1 Newton. So in other words, 1 Newton is the force that we have to exert to hold the mass of 100 grams on your palm. So when I say other words, means this one is going to weigh 100 grams. So accordingly, if I am going to place it on my hand, then what will happen? I will have to give a force of 100 grams to make it be like this. See, this is 100 grams, so it is not going to be a problem. Suppose I make this as 10 kg. And then somebody puts in my hand. Will I be able to resist it like this? No. What will happen? I start falling down. Okay. Will have to start गिरने लगे, because it is not going to be so easy to handle 10 kg on my hand easily. So what will happen? It is going to fall. So at that time, what is required from me? I will have to give a upward force in such a way that I can hold this in this position. Otherwise, what will happen? This will start falling down, because it will pull my hand downwards. So I need to have that much force upwards so that this is getting balanced. Hence, when we say that 1 Newton, so what is 1 Newton force? It is the amount of force exerted. Okay, it is the amount of force exerted to hold this mass of 100 grams. That is nothing but the 1 Newton. So now there is one. Do you know? A body in which the interspacing between its constituent particles do not change when a force is applied on it is called a rigid body. We already saw that rigid and non-rigid bodies earlier. So what is a rigid body? A body in which when I am pressing this thing, the intermolecular spaces are not increasing or decreasing, so it is remaining in the same shape or size. So when a body with its spacing between its constituent particles do not change when a force is applied on it is called as a rigid body, and if it changes, the body is a non-rigid body. So if it changes, like I told you the example of my handkerchief, so I am able to squeeze it, that means it is a non-rigid body. A force when applied on a rigid body can cause only motion in it. If I apply force on this, the only thing I can bring about is a motion. I cannot change the shape or size of this thing because it's a rigid body. In a rigid body, I cannot change the shape. मैं कितना भी कुछ भी करूँ, मैं कुछ नहीं कर सकता हूँ. But yes, I can throw it upwards, downwards, जो करना है मैं कर सकता हूँ. That thing is, I can only change the motion of the body if it is a rigid body. But a force when applied on a non-rigid body, like my handkerchief, when it is applied on a non-rigid body over here, then it can cause both the change in size, shape or motion. I can bring it upward, downward also. I can play with it like this. So motion is possible. I can make it like this. Okay, so a change in shape and size possible. I can increase it. I can open it up. So you see that when I am using a non-rigid body, I can change the shape or size as well as motion of the body. But if I am using a rigid body, I can only change the state, that is motion of the body. So that is what we learned about the force. That was force. Again, we can recap a bit. Force is that physical quantity or the cause which changes or the state of the body. That is, you can either change the state of rest or of motion of the body, or change the direction of the motion of the body, or it can either change the shape or size of the body. Okay, so we need two things for identifying a force. One is the magnitude, I erase that. One is the magnitude, that is the number, that is the value of that thing, magnitude, and other is the direction of that force. So magnitude and direction both are required for understanding the force. The units of force are Newton. 1 Newton can be defined as 1 Newton is a force which when applied on a body of mass 1 kg produces a speed of 1 meter per second square every second on for 1 second. So that is why it is 1 kg into 1 meter per second square upon that is the acceleration. We also know that weight is nothing but the force due to gravity on the body. So weight is force due to gravity on the body, and 1 kg mass will be 1 kg F, and 1 kg F is equal to 10 newtons or 9.8 newtons. So that is how we are going to define the force and the different things possible about force. I think I'll end the video for this one way, and we'll continue further in the next video.